Welcome to Hurricanes in the Gulf of Mexico, why they are stronger and how to be ready. I'm Julia Kress and I'm a member of Fondren Library's Green Team. The Green Team is presenting this program as part of Communities Responding to Extreme Weather Climate Prep Week, which runs from September 24th to the 30th every year. This week is dedicated to learning, service, and actions to prepare our communities for extreme weather. Climate change is everywhere. Just this past weekend, there were climate protests around the world. A recent New York Times article titled "Shows Why." Is this the coldest summer of the rest of our lives? The answer to that question is yes. It is highly probable that summers are only going to get hotter. This is upsetting, to say the least. However, we must be resilient and we must not be despondent. We can educate ourselves about the changing climate and be prepared for the next extreme weather event in our area. In Houston, hurricanes and flooding remain the greatest threat. As part of being ready, the Green Team is giving away 3 solar-powered crank radios with flashlight and phone charger. I'm going to share the QR code to enter this giveaway right now, and we will announce the winners at the end of the program. Our first speakers will educate us about why hurricanes are stronger. Professor Sylvia Dee is a Rice climate scientist specializing in atmospheric modeling, climate change impacts, and paleoclimate data model comparison. Her work focuses on analyzing climate data spanning the past, present, and future, and improving climate predictions to characterize risk. Dr. Lizzie Wallace is a Rice Academy Postdoctoral Fellow in Earth, Environmental, and Planetary Sciences. She is working to integrate natural archives of local hurricane strikes in the Atlantic with hurricane modeling data to show how and why hurricanes in the Gulf of Mexico have changed over the past 200 years. Her goal is to provide coastal communities like Houston with long-term information on the scale and probability of hurricane events. Just this month, an article was published about Professor Dee and Dr. Wallace's exciting work entitled "Nature's Archive Reveals Atlantic Tempests Through Time." I will put a link to this article in the chat. Please welcome Professor Dee and Dr. Wallace.
Hi, thank you so much. So I'm going to give an overview of tropical cyclones in general, and then, as Julia just mentioned, Dr. Lizzie Wallace will follow up with some information that we have from climate model simulations about how we think tropical cyclones and hurricanes are changing now. So tropical cyclones can include hurricanes, and they're also called typhoons in other parts of the world, specifically in the Pacific. These storms can be up to 1,000 kilometers in diameter, such as this storm depicted here on the left side of the screen, which spans the entire width of Florida. So these can be gigantic storms with far-reaching impacts. If we think about the anatomy of a hurricane or a tropical cyclone, they're characterized by 3 main features. One is rain bands that spiral outwards from the center of the storm. Hurricanes have an eye and an eye wall in the very center of the storm. And finally, these storms rotate. Here are some satellite images of 2 storms, which clearly show these 3 features. You can see the center of the storm where there are relatively calm conditions, the spiral rain bands extending outwards around the storm. And as we see, if we take a look at live videos of these storms, they are spinning, they're rotating. Here's another picture showing the eye of the storm. And so I have a little video here that shows a little more information about the calm in the middle of the storm.
The eye of a hurricane is its most distinctive feature. They are formed when the converging surface winds, shown by these blue arrows, become strong enough near the center that the Coriolis force deflects them to the right. The strong pressure gradient balances the Coriolis force here, preventing the winds from reaching the exact center, so the eye is actually very calm. Eyes can become visible by satellites when enough air at the top of the eye wall is forced inward. The convergence of this inward forced air causes it to sink. As it does so, the air compresses and warms, evaporating the clouds and creating the clear skies we associate with the eye.
So without getting into advanced tropical meteorology, a little bit about eye walls of hurricanes. We know that hurricanes tend to be associated with large rainfall. So this map shows the rainfall impacts from Hurricane Rita in 2005. And you can see that as the storm moves across the landscape over the ocean, it's associated with really heavy rainfall. We also have a lot of information, especially over the satellite air, about hurricane tracks. This is all of the tropical cyclones from 1851 in the Atlantic, when we started to have ship track data, and from 1949 in the Pacific. A couple features to note is we tend to see these C-shaped tracks. And if we extend this view out into a global map of tropical cyclones from 1945 to 2006, we can see a few features, a few key features. One is those C-shaped tracks in both the Pacific and the Atlantic Ocean. There are also typhoons and hurricanes that form in the Southern Hemisphere. You'll notice there are no hurricanes forming across the equator, and that's due to the fact that the Coriolis force is 0 at the equator. So to have that rotation characteristic that these storms need to get going, they have to be sufficiently far from the equator. And then finally, there are no hurricanes or tropical cyclones in the South Atlantic, and that has to do with wind shear, which I'll charge the students to take my climate change class to learn more about. So a few characteristics about tropical cyclones next. We know that tropical cyclones tend to form in late summer or early fall. So depending on whether we're in the Southern Hemisphere or the Northern Hemisphere, here the months are switched on this x-axis, we have the maximum amount of cyclogenesis or hurricane formation when the sea surface temperatures are the warmest during the season. So again, this tends to be in late summer and early fall when the ocean has accumulated a maximum amount of heat. Here's a similar graph for the Atlantic basin showing you the total number of cyclones that form category 3 or greater hurricanes and named systems from January 1st through December 1st. So once again, we can see that starting around June, we have a large uptick in the number of named storms per year over the last 50 years or so. Tropical cyclones grow in a very specific way. First, we have wind perturbations, which influence evaporation, increasing tropical cyclone intensity, and it's a feedback loop. The first characteristic that we need in order for a tropical cyclone formation is warm waters of about 80 degrees Fahrenheit through a sufficient depth in the water column. We also need high humidity. Where there's a great deal of moisture in the atmosphere, we get favorable conditions for the tropical disturbance to develop. We generally need, as I mentioned earlier, about 350 miles or so away from the equator or 5 degrees of latitude for the Coriolis force to take effect. And then finally, we need a low pressure disturbance. So usually this occurs as a group of thunderstorms that start to interact and spin in the tropics. We need a weakly organized convective system with sizable spin and inflow at the surface. So we call this, oops, sorry about that. Can you all still see my screen? Let me try to resume my share. It's strange. Can you see my screen? I apologize, technical difficulties. Okay, how about now? Better? Great, sorry. Yeah. So coming back to cyclogenesis, essentially it boils down to 3 points. Warm waters fuel the heat engine of the tropical cyclone. We have thunderstorm activity, which can move the heat stored in the surface ocean into the atmosphere. And then we have the Coriolis force, which generates that spinning of the storm. Tropical cyclones intensify as they move over areas of warmer water, and they weaken once they make landfall. So here are two or three tropical cyclone tracks, and you can watch as the storm develops just from a tropical depression into a tropical storm, into a hurricane as it's moving over that warm water mass. And eventually, as they make landfall, they dissipate. One of the things I wanted to mention is that during the past 30 years or so, there have been substantial improvements in our ability to do hurricane track forecasts. So we've really improved our technology in terms of being able to know, for example, where hurricanes will make landfall with high accuracy up to several days in advance. However, and as we'll talk about later in this introduction, we've only made minimal improvements in understanding how intense a hurricane will be once it makes landfall. We classify hurricanes using a scale called the Saffir-Simpson scale. So you've probably heard on the news, Category 1 or Category 3 hurricanes. So tropical cyclone categories are dependent on their wind speed primarily, with Category 1 being about 70 to 90, and then Category 5 being about 160 miles per hour or higher. And we can characterize the damage associated with these storms in terms of how much wind damage we have, as well as storm surge and flooding. As you can imagine, we tend to see more Category 1 hurricanes than we do those really catastrophic Category 5 hurricanes. This is the number of hurricanes on the y-axis and their category on the x-axis. So again, much more 1, 2, and 3 category, very few 5s. Just a couple years ago, Hurricane Irma generated some discussion amongst meteorologists about whether or not we should define a Category 6 hurricane on the Saffir-Simpson scale, because its maximum wind speeds reached about 185 miles per hour, which is sufficiently far off the scale of the wind speeds we had observed in other storms. But as you may have read in the news, no, Hurricane Irma was not classified as a Category 6 storm, despite its very large damage to infrastructure and disruption to our lives. So we're sticking to the 1 through 5 for now. So a few notes about damage and costs on that note. We know that tropical cyclones can be damaging due to the wind speeds, which damage infrastructure, torrential downpours, which can cause flooding, and compounding that is storm surge, which can do damage to coastal structures as well. Storm surge really refers to the fact that these storms can pretty much blow a mound of water towards the coastline, right? The wind speeds are so high that it's mobilizing basically this wall of water pushing up against the coast. And if any of you lived through Hurricane Katrina, the storm surge was primarily responsible for a lot of the flooding that impacted New Orleans. There are many storms in the last 10 years or so that have had catastrophic cost and damage to infrastructure. Hurricane Sandy, for those of you who are on the East Coast, flooded the New York City subway system. We saw that just a couple weeks ago with another storm. This is a picture of, one of those boardwalk towns being totally underwater. So again, high cost. In Houston, we know of many different hurricanes that have affected our city and imparted loss of life. One of the biggest ones was the 1900 Galveston hurricane, which is actually the greatest loss of life of any US meteorological event. Up to 8,000 people died. And partially this was such a destructive storm because we didn't have the forecasting system and the early warning systems that we had, that we have today. Hurricane Allison in 2001, high rainfall accumulations, 25 inches and higher in some regions in Louisiana and in the Houston area. About $5 billion, killed about 41 people along the Gulf Coast. And then most recently, Hurricane Harvey really blew those rainfall accumulations out of the water, where we had between 45 and 50 inches in some parts around Houston proper. I always show this picture. You've probably all driven through this intersection of Memorial and Shepherd. I don't really know why this gentleman is smiling, because this storm cost us $125 billion, right? This was a very, very expensive storm. This is a picture of downtown Houston after Harvey. Many areas of the city were severely flooded. And if we look at the rainfall accumulations once more for Harvey, some of them in the outskirts of Houston were even pushing 60 inches. So 60 inches is about, some of your heights. So that's really pretty severe amount of rain. I just wanted to show some quick field photo after Harvey. We actually went out on a monitoring cruise in Galveston Bay with our collaborators at Texas A&M Galveston, and we had an opportunity to measure everything from kicked up pollution from the sediments that gets pushed into the ocean, right? There are fish die-offs after hurricanes. There's disruptions to ecosystems caused by these hurricanes as well. And then getting into the cost, every time I give this talk, I have to update my 10 costliest US hurricanes. Every year we have another very expensive hurricane to add to this list. You can always go to the NOAA Hurricane Center and look at the top 5 costliest hurricanes on record, right? Katrina cost $161 billion, Harvey $125 billion, and really counting. And as we've seen in the last 2 years, Houston, we've really gotten by scot-free, while our neighbors just east of us in Louisiana have gone through Delta and Laura. And so it's really just a matter of time before one of these larger storms affects us. And this is not surprising. We know that as the number of water-related billion-dollar events is increasing over time, their cost is also increasing over time. And at the end of the day, this can be explained by simple thermodynamics. As we warm up the atmosphere, it can hold more water vapor. So a warmer atmosphere, if you've ever been outside in the summer and it's more humid, you know what I'm talking about, leads to higher precipitation events. And so as we cause atmospheric warming through anthropogenic activities, we can expect more rainfall associated with these storms and thus potentially more flooding. So the billions of dollar question about hurricanes and climate change that Dr. Wallace is going to address next is, if we track hurricane intensity and severity over time, do we see the impacts of anthropogenic climate change increasing hurricane severity? This graph shows what we call the power dissipation index for storms, which is the power dissipated by the storm over its lifetime by the winds. We can see that over the last several decades, there's been a uniform increase in Atlantic sea surface temperatures and power dissipation index for storms. So with that, let's transition to the question of, is climate change causing more frequent and more intense hurricanes? I'll put this blog post in the chat, but otherwise I'll turn it over to my colleague, Dr. Wallace.
Right, thanks, Sylvia. That was a great intro to hurricanes. I'm gonna share my screen now for everyone. All right, can everyone see my slides? All right, so now that we know a bit about how hurricanes form, it's important for us to think about how hurricanes will change with global warming. And there's sort of 4 aspects of storms that we're concerned with. The first of which is frequency. So how often are these storms forming? We know that we're getting a certain number of storms in the Atlantic each year, but do we expect that number to go up or down in the future as we warm our climate? Another thing we're concerned with is storm intensity. So as Sylvia mentioned, hurricane wind speeds can cause massive destruction, and we usually sort storms according to the Saffir-Simpson scale. So do we expect there to be more intense storms in the future or less intense storms? Going along with that, rainfall is one of the main reasons that we see hurricane destruction. And do we expect storms to be more or less rainy in the future? And finally, we want to know something about hurricane speed. So hurricanes that move really slowly will park over cities for long time periods and cause more destruction. So we want to know, are hurricanes moving faster in the future or slower? And so I thought it would be fun in the beginning for us to take a turn and sort of predict how storms will change with global warming. And so I think Julia has a poll that she's going to send out to all of you. So if you guys could just answer this poll, just tell me whether you think hurricane frequency is going to go up or down or stay the same in the future. All right, we've got 85% participating, so I'm going to give you guys like 10 more seconds. So if you're wavering on your answer, just throw in a guess and we'll see how it goes. All right, let's end the poll and let's take, oh, I think I can share the results for all of you. So if you guys, can you guys see the results? I can read them aloud if not.
Can you see it? I shared it.
Now
Okay.
I see it, yes.
Okay, great. So it looks like most of us are thinking that we're going to see an increase in storm frequency, an increase in storm intensity, an increase in rainfall, and storms are going to move faster in the future. All right, so now I'm just going to walk us through what we know as what scientists know about these questions. So the first question, I guess I have to, yes, okay. How will hurricane frequency change? So it turns out that even though we all thought that hurricanes were going to increase in the future, hurricane frequency was going to increase in the future, that's actually one area of like pretty active research in the scientific community. So we really don't know whether hurricanes will increase in frequency or decrease in frequency in the future. In fact, most studies are suggesting that storms are going to get less frequent. This image is showing what many different models project for storms out to 2100. And so you can see some models suggest that we're going to see an increase in the number of storms globally. Another subset of models suggest a decrease. There are more models in this decrease category. And so we generally think that we're going to have less frequent storms in the future. But how will the intensity of these storms change? So most of us rightly projected that we're going to see an increase in storm intensity. This is true. It's pretty well established that the global average of hurricane intensity is going to increase in the future. We're also going to see more intense of these really intense storms. So category 4 and 5 storms are going to go up. So here you can see an image showing the percent change over the 21st century of different types of tropical cyclones. And you can see that the number of these lower intensity storms is going down. So we're seeing a decrease in storms, but of the ones that we're getting, more of them are going to be these category 4 and 5 hurricanes that cause massive destruction at our coastline. And so moving right along, we also want to know sort of how will hurricane rainfall change? Most of us predicted, I believe, that we're going to see an increase in hurricane rainfall. And Sylvia hinted at this, and yes, it is true. We expect that tropical cyclone rainfall rates will increase in the future. So when we have warmer air, the air can hold more moisture. And so if we see about 1 degree increase in temperature globally, we're expected that the air is going to be able to hold about 4% more water vapor. And so storms like hurricanes are going to have a lot more rain associated with them. And actually, scientists have looked at hurricane risk rainfall rates for cities. So in particular, Houston was a big area of interest after Harvey. And so here you can see a plot showing the 100-year flood. This is something that we use to design buildings all the time. And it's what we use to like project risk and for cities. And so in today's climate, the 100-year rainfall event would be an 11 inches. And in the future, it's projected to be about 18 inches. Just for scale, Harvey was a really unprecedented storm. You couldn't even plot it on this plot. It was 60 inches of rain, so almost 3 times what the 100-year flood for the future is projected to be. Finally, hurricane speed. So I think we all thought storms were going to get faster, but again, this is another area where we don't really have a scientific consensus. Observations suggest that there's been a 10% global slowdown in storms, and this is mostly because summertime winds in the tropics are expected to get slower with global warming. But this is something that scientists are still actively working to figure out. And so just to sort of sum up what we know about how hurricanes are changing, we know that we're going to get it's expected that we're going to get less frequent storms, but the storms we do have are going to be more intense and more rainy. But we still don't really know whether they're going to speed up or slow down, but current studies suggest that they're slowing down. So these rainy storms will park over cities for longer. But one thing that we do know is that our coastlines are becoming more populated. Here you can see population change in coastal watershed counties over the last 40 years in the US. And so all these blue colors are indicating counties that have seen an increase in population. And so we've seen most places along our coastline growing in population. And these cities are becoming more vulnerable because there's been a lot of local sea level rise. In particular, Texas has seen some of the most sea level rise over the last 40 years, with Galveston measuring it at about 12 inches of local sea level rise. And so we really need to do a lot of work to be prepared for these storms so that we don't see the destruction that we've seen with past hurricanes. So with that, I'll just conclude. And I think Sylvia and I are going to be answering questions if anyone has any.
You can post your questions in the chat, or you can just ask it if anyone has any questions. I see one question. Will the Ike Dike really work?
I do not know what the Ike Dike is, so I'm going to let you answer that.
We're both pretty new to Houston. I think we would need to, phone a friend in civil engineering to ask that question.
Well, the Ike Dike, this is Kathy Jones, is like a big dike that they would build at the entrance to the Galveston in the ship channel into Houston to prevent the storm surge from coming back in. Much like they built one, I think, over in Europe somewhere. And it's similar to that, billions of dollars. So just curious.
The Netherlands have them also working real well.
Yeah, that's where I'm thinking the Netherlands has it. Yeah.
I would say probably it will work if they use the design flood projected for global climate change. Yeah, I don't actually know like what sort of estimates are going into their calculations for creating something like that.
I bet Daniel knows the answer, or maybe.
So there are different proposals going around. The Army Corps of Engineers, I think, just released an update of its plan. There are different proposals from the Speed Center and from that professor at, Texas A&M Galveston. The idea is it would actually extend along a long part of Galveston and on Bolivar Peninsula. Some plans would protect like the back end of the bay and the Clear Lake area. The main thing it's aimed for is for the storm surge, is for the type, gets the name Ike Dike because Ike Dike is when we had the extreme wind, but it passed through very quickly, and so it's aimed at blocking the surge. It would have alleviated a lot of the harm then, or the worst harm that could have happened if that surge had pushed up through the ship channel. It would have done nothing for Harvey. It would do nothing for a big rain event or a big wind event. It really can only protect against the surge.
Thank you so much, Daniel. I see another question. Do we know if the wind patterns, current paths are changing? It says so more on the Gulf Coast, or more on the Atlantic coast than the Gulf Coast.
If I'm getting the question right, I think you're asking whether winds are going to steer storms differently. I don't know that that is a well understood part of science of hurricanes in the future. I know that recent work has found that storms are going to be moving more towards the coast. So we're going to have more of these sort of easterly winds that are pushing storms up against coasts like the East Coast. But I don't know yet if we have a good sense for how winds are going to shift storms either straight moving into the Gulf or recurving along the East Coast.
Dr. Wallace and I are actually working on a project right now to classify how density of storm tracks coming into the Gulf versus other parts of the Atlantic coast is altered by different climate forcing, like greenhouse gas forcing, for example.
Yeah, that's what I was asking. Thank you.
I see that Richard has a question. To what extent is infrastructure designed and built today taking into account future climate projections?
Again, I don't know if I actually know the answer to this question. Yeah, I would guess it's regional. So
Yeah, it's very regional. I think that the 100-year flood / storm surge is now being recognized as not stringent enough in many parts of the East Coast. I know that the Army Corps of Engineers is starting to really take a hard look at their flood control design for the Mississippi River Basin. I don't know what infrastructure design is based on for the Galveston Bay area, but I would naively assume that it's based on 20th century data and not on future projections, but I could be wrong.
And yeah, if some of these questions are out of your purview, don't worry about it, There's another question. Is there an active effort to measure whether the incremental widening projects along Gray's Bayou are working? I'm not sure if that's part of your work. That sounds like maybe Jim Blackburn could answer that one. I don't think he joined us today, but and then I see another question. I heard that scientists are working on a way of injecting some type of material into storms far from shore to try and reduce their intensity. Do you know if this is a possibility?
Yes, the nuke at the hurricanes myth. I have heard about that, and I don't know that the answer is no, that will not work. I don't know, Lizzie, if you want to talk a little bit. I mean, there was some confusion in the community about this because dust, Saharan dust, can sometimes suppress hurricane formation. So I don't know, Lizzie, do you want to back end that question?
I would generally say that this wouldn't work out. I don't exactly know practically how you would do that, but yes, dust in the air will dry out hurricanes to a certain extent and prevent them from becoming more intense. But I don't know if you could just like fly a plane in and throw dust in a storm. I would say this is probably a myth, but an interesting idea.
Well, everyone's trying to come up with something, right? Now,
Yeah.
I actually have a question. How do you find the material in doing your research, like the natural evidence of hurricanes from 100 to 200 years ago to apply to your research?
Yeah, so what I do is create sediment reconstructions of storms. So the idea is you go to a coastal pond that typically accumulates fine mud. During a storm event, you get high winds and waves and storm surge that throw sand from the beach back into this coastal pond. Then you can take a super long sediment core. You can find these sand layers interspersed among the fine mud that's typically in the pond. You date those sand layers, and then you know when hurricanes struck that particular location for 1,000 years. And so we've been doing that all over the US coastline.
That is really interesting. Okay, I see one last question, and then we're going to move on to our next speaker. How do you approach the issue of climate anxiety with your students, and how do you manage that yourself?
I can tell you how I manage it for my students. So how do I approach the issue of climate anxiety? I am given tremendous hope by the innovation of my students and my classes. I think that the more that we train our next workforce to be solutions oriented as much as possible, we can start to have an attitude within our broader community of, don't panic, keep calm, carry on, start thinking about fixing it at all times. I often give my students comparisons to other global catastrophes, be it a pandemic, which we just developed a vaccine for in a very short amount of time. I think with the right incentives and the right public understanding, we can solve this problem. It is a solvable problem. So that is sort of how I pitch it to K through 12 students and undergraduates that I work with. As far as my own climate anxiety, it's a struggle. I think we all feel burdened by the constant deluge of news about half the country being on fire and the other half being underwater. And I think all we can do is continue to work as a team and work with policymakers to address the problem head on and fast as we can.
Thank you.
So I'm going to introduce our next speaker now. So we have Hollie Evans here today, who was appointed by Drusha Cash, who is Rice's Director of Crisis Management, to speak at this event. Hollie is Rice's Campus Events Manager and has been a member of the Crisis Management team for 3 years now. She is trained in Incident Command System and has been doing hurricane response work for over 10 years. She enjoys tracking hurricanes and teaching others about hurricane preparation in her spare time. So you can take it away now, Hollie.
Thank you so much, Ashley. First of all, thank you, Professor Dee and Dr. Wallace. I enjoyed that thoroughly. I love anything hurricane. So, and I'm gonna just piggyback on what you said a little bit in my presentation. So I'm glad that you guys started first. So really what we're gonna be talking about is understanding all of the things that they talked about, how you can use that to build personal resiliency after these crises come to campus. And we're going to look at all the different kind of hazards that Rice are potentially going to face, but then we'll focus specifically on hurricanes. Let's see. Here we go. As we just discussed, the frequency and severity of hurricanes, as you can see, have continued to rise over the last 10 years. And, you know, as they just talked on why these things are happening, our climate is continuously changing. And so when we look at these different storms and how they're continuing to increase and the frequency, we look at how can we potentially, as an institution and as a community, work to be prepared for those and how we can mitigate some of those based on the history that we've had here in our community. So in order for us to be prepared, some of the things that we do ahead of time is mitigation. And we've been working on mitigation at the Rice campus for several years now. I'm sorry, I have dogs. And we will continue to work on that with FEMA and with our facilities engineering and planning team. There's some projects that have happened on campus already to help with flooding. They've also done projects to harden the buildings against wind damage so that we're more resilient when these storms come, and we're definitely more prepared. Additionally, in preparation, it's good to understand your risks ahead of time, know how to prepare for those risks. I apologize. Someone is like sawing outside my window. And also then, what are your personal preparedness responsibilities? To be resilient as an individual, you have to be prepared on your own. And so we'll go over what you can do to work on your personal resiliency. So there are a lot of hazards and risks at the Rice community beyond just hurricanes. And if you go to emergency.rice.edu, you can actually click through each of these different risks and hazards, and it will tell you exactly what to do. Literally, it says what to do. What do we do as an employee or a student here at the Rice community? And what do we do whenever we get home in order to plan for or respond to these types of incidents? We did a detailed deep dive into what are all the potential risks for Rice. And of course, hurricanes and tropical storms, thunderstorms and flooding, even potential wind or tornado threats are all weather-related risks that we have at the university. So whenever we look at this, we're not just thinking through what might happen, we're thinking through, okay, how can we be prepared if those things happen? How can we learn from incidents that have already happened, like from Harvey and those larger storms, and how we got through those. So the first thing everyone should do, if you haven't already visited multiple times, is go to emergency.rice.edu and go to that what to do page for each of those potential hazards. It will give you tons of information, as I said, on what you should do in your own office, what you should do in your department. If you're a leader, how you should communicate with your staff and your team. And then also what you should do whenever you get home to prepare for your family and your household and get them ready. Make sure that you're talking to your department leadership and understand, and you guys have a good plan on what to do in each of those situations. And do that yearly. Don't just wait until a storm is coming in the Gulf and we have 3 days notice. Start before hurricane season and say, okay, what's our plan for hurricane season again? What are we gonna do with our computers? What are we gonna do with our grad students? What are we gonna do with our labs? Make sure that you know the plan. We're going to get new staff. We're going to get new grad students. We're going to get new undergrad students. Make sure that everyone has a great understanding of what the plan is and what each of their role in that plan is. And you want to make sure, again, to do that every single year. When you get your situation at Rice settled, you know what your role is, you've done what you need to do, then it's really important to take care of yourself, your family, and your household. And a lot of folks, like Professor Dee, are not from the Houston area, and maybe they haven't lived in an area where hurricanes are really a problem. So it's always great for them to go ahead and research and prepare for a hurricane. Personally, as soon as hurricane starts, I've got tons of extra water, batteries, my flashlights are ready to go. Everything's good to go. I've lived here my entire life. I've been through dozens and dozens of storms. But for those of us who it's not something that you just automatically do, there's a great tool if you go to ready.gov, and they will walk you through how to build a plan for your family for all kinds of emergencies, not just hurricanes. To create a plan if you have a fire in your house for your family, if you are going to have to evacuate, what you should bring. It has so many great tools, and I always send everyone to that website. For building a preparedness kit, do you have animals? Do you have medicine? Do you have elderly? What numbers should you call if you need to tell someone you might need someone to pick you up if you're unable to get out? All of that information is on this site, so it is a great tool to share with everyone in your department, share with your students, and then actually go through the process. There's really great checklists for you to go over all of these different items. Also, if you follow Rice Crisis Management on social media, we try to share those tips as storms are coming through, and that's Rice at Rice Alert, and we'll share all these fun little graphics like you see here on things to do to make sure that you know how to get prepared. So resiliency from a storm is really how well did you prepare for the storm? If you were really well prepared, if you took the steps ahead of time, then you're going to have a greater resiliency after the storm to be able to bounce back, to be able to take care of the things that you need to take care of at home, take care of the things that you need to take care of at your office, because you were not only physically prepared with the things, but you were mentally prepared for what could potentially happen. And so the more knowledgeable you are about the risks in your area for these storms will make you more resilient in the end. So what I did was put together a little quiz that we're going to take, and you guys can take score of how many of these tasks you would be prepared for if we had a storm tomorrow. Okay, so you get 1 point for each of these that you feel like you could do tomorrow. Could you shut off the power to your home and know where the breaker box and how to operate the breakers? Do you know where and how to operate the main water shutoff valve? Do you know how to repair a broken pipe in your home? Do you have additional plumbing supplies available for emergencies? How many needed those during the winter storm? Do you know how to and can build a fire? And if so, do you actually have matches? If you can do it without matches, you get an extra bonus point. Do you have an alternative heat source in your home and actually know how to operate it? And if you think that the alternate heat source is a barbecue unit or your stove, take a point away. You lose a point. And then also, do you own a generator, which are like gold here in Houston? Can you operate that generator? If you have fuel storage for your generator, you get another point. But minus a point if you have more than 25 gallons inside your residence, because we do not want a fire hazard. Have you stored food for the last 30 days, as well as water? Do you have stored water to flush the toilets? Bathtubs are great for this. Can you prepare the stored food that you actually purchased over an open flame? And do you have a pre-established plan to communicate with your family in times of a crisis or emergency? If you have that emergency communication plan, do you have the equipment to do so? Do you have all your charging cords and alternating charging sources charged and ready to use? And if you have if you filled up your vehicle with fuel before an incident occurs? And do you have enough medicine to last you 30 days? Okay, add up your totals together. If you have at least between 20 and 22 points, you're ready to go. You're going to have a very resilient bounce back after the storm. You're prepared ahead of time. You have what you need, whether we're having a freeze or we're having a hurricane. If you're between 15 and 20, you're doing a good job, but you probably want to just work a little bit more on your plan to get prepared. 10 to 15, let's make a list. And less than 10, let's set up a chat. No, I probably have a little more work to do. So that's really all. That's really the gist of my presentation, but really just to stress that the more you prepare ahead of time for these storms, and if you're not from the area and you're unsure what to do, there's tons of resources. Reach out to those resources and use them, and go to emergency.rice.edu. There's so much information there, and there's so much specific to what we do here at the university through crisis management. We post updates there regularly. If there is a storm and you're wondering, are we monitoring it? We'll actually put a banner. We know there's a storm coming, we're watching it. And then as we get updates from NOAA, we'll put them there. So if you're ever curious what's going on, that's always a great place to get information for Rice. And that's it. Does anyone have any questions? Thank you for being patient with my dog.
I actually have a question.
Okay, great.
I have never seen 30 days to have 30 days of water and 30 days of food. I mean, it makes sense, right? If you were stuck in Louisiana during what happened this year, particularly last year, but I always have heard 3 days. So it's 30.
Yes. So I always say prepare for a month, like for the entire season. In general, they like to hope that within 3 to 5 days we'll get electricity back going and everything. But if you look at areas of Louisiana right now, they're in 6 weeks without electricity right now in some of those areas, which is just absolutely insane. And they're in remote areas. It's really hard to get to places that actually have it. So I think that it's really great to what I do is I get like a little tub, a clear tub, and I just put all of those things and I put a lid on it so we don't use them in our daily lives, right? And we were like, oh wait, that can of beans, I could have used them. No, just leave what you have in there. And then don't forget to recycle them out. When you get to the end of hurricane season, then you can eat the beans or the ramen or the whatever the case may be. And to recycle that and redo those every single year.
And I think that's the thing too, is it's not something that you check off your list and you're done. It's something that every year you have to be thinking about. And I think that that's a place where people get it all together. I mean, at least I do for 3 days, right? Not 30. And then I think I'm done, and you're not. Every year, like it's almost like every March or April, February even,
Right.
You need to set, it's like house maintenance, right? Just one of those things. Every year you got to take the time and you got to do this, because if not, you're going to be more stressed out when something's headed our way. And that's when things fly off the shelves and nobody has anything in stock.
And additionally, like if you have a really important responsibility at Rice, if you're on the crisis management team, if you're a lab supervisor and you're going to have to write out those kind of jobs, if you've done it at home ahead of time, then it's not an extra stress that you're worrying about, because you know that your people at home are taken care of and you can just worry about your job at Rice. So that also, just makes a huge difference.
Well, and I think that's a great point, Holly, is right. Like you have to be prepared at work, right? Work should be doing that, but all the employees need, that work anywhere have to be prepared at their own home Because if they aren't going to be able to help out at work in an emergency. They're going to be at home. So I think it's really important, like how you're talking about, take care of yourself, because if staff doesn't do that, they're not going to be able to come to work.
Absolutely.
I do see some questions here.
So yeah, Jordan's question about the generator. Yeah, generators in apartments can potentially be very dangerous because when you have a generator going, you want to make sure you get it far enough away from any of your windows or doors that you're not getting carbon monoxide in, because then we do have a lot of carbon monoxide deaths, unfortunately, related to winter to these tropical storms. But what you might do is they have like little travel stoves and you can get propane. So for working on cooking your food, those things are something that you could use indoors. That would be a lot safer than trying to get a generator set up. And to Charlotte's question, there are great plans on how to take care of your animals and all the things that you should pack and include, including how much food to have for them. Make sure you have some type of carrier. Another great example in Louisiana, there were so many animals from different shelters that needed to be moved, and they were able to successfully do that because they each had their own crate and like their medicines, things like that. All of that information, there's a specific pet checklist on that ready.gov. So definitely check it out. Thanks, Julia.
Oh yeah, and thank you so much. It looks like we're just going to end maybe a few minutes early unless there's any last comments or questions. This has been really fabulous.
Yeah, I can announce the winners of the radio flashlight that I accidentally had my cat send a minute ago in the chat. So we did a random like generator to pull our winners. And so the 3 people that will be receiving one of the radios are Madison Roy, Dan Bromberg, and Lori Sandell. So we will, I believe, have those at Fondren for you guys to pick up. And we have your email, so we'll email with you guys if you're here with specific instructions on how to get that or how we can get that to you.
Yeah, and you'll pick those up next week. That's the plan. So we will email the winners. Thank you so much, everyone, for joining us. Oh, let me share. I have to share one thing. I'm forgetting. We do have, just for more information. Oops, there we go. And so here's everybody's email addresses, and then the different, the Climate Resiliency Hub website for the library, as well as CREW's website. And CREW is actually the ones that put on Climate Prep Week. And so they have a lot of great information on their website. And they offer a lot of interesting resources to everyone. So I encourage you to check out climatecrew.org if you want more information, as well as the Climate Resiliency Hub website. Okay, well, thank you, everyone. And please reach out if you have any questions.
Thank you.
Thanks a bunch, everyone.
Thank you, Julia.
Oh, yeah, thank you so much. And I would love to stop by and meet you too.
Yeah, I'm around.
I am fascinated with this. I mean, it just so much to learn in so many different ways, right? Like the questions that we got about the engineering of it all. That's a whole different.
Let's get Jamie Pageant in here next time.